Good afternoon, ladies and gentlemen. Welcome to this webinar on understanding modern train control. It's my great pleasure to welcome you to this webinar. We've got a full house this afternoon, so we're very excited to be presenting this webinar with Dr. Frank Heibel. Just while we wait and allow people to come into the waiting room, we'll come from the waiting room into the virtual room. I might just ask if you can do me a favor. If you could tell me where you're coming in from, and if you feel comfortable, which organization you're representing. That's always good to know. We do have a global audience on many of these webinars. It's always good to know which part of the world we've got attendees tuning in from. But in the meantime, and you can do that through the chat box at the bottom of your toolbar, so that you should see a chat option. It's always good to see where we've got people coming in from. So just while we're doing that, thank you, Constance. We've got someone from Melbourne, from EGIS. Thank you very much. Welcome. Thank you so much for joining us. And like I said, we do have a full house, so very excited to have you on board. Frank, how you doing this afternoon?
I'm fantastic. Thank you very much. I'm looking really forward to this. I see some familiar names in the attendee list that I'm watching right now. That's why I didn't look into the camera. So it's really, really good. I hope you don't expect a masterclass in like 45 minutes or so. That's not the purpose of today, but I'll tell you what my purpose is in just a second.
Yeah, absolutely. So just whilst we wait for allow the maximum number of people to join before we officially kickstart, as a way of introduction, my name's Fossey Kurushi. I'm the General Manager at Informa Connect Academy, and we've got a whole jam-packed series of curriculum of learning related to Frank's expertise. So we're all very excited to be working with you, Frank, and it's a great pleasure of mine to be collaborating with you on this as a way to get the initial sort of first partnership underway. We thought we'd do this webinar, and like I said, we've got many people who obviously recognize your expertise. So it's fantastic to have you working with us. Just as a way of housekeeping before we officially kickstart, there are normally two quick questions that we always get when we do these webinars. The first is, will this presentation be recorded? And the answer to that is yes, you will get a recording of this presentation post webinar. And the second question is, will there be Q&A? So I would like to highly encourage everyone to ask questions if you have them. What we'll do is we'll take them right at the end. So as you progress throughout the presentation, feel free to use the chat box option or the Q&A option. So there's two options at the bottom of your toolbar to be able to ask questions. Frank's assured me that he's more than happy to ask and answer any and all questions, easy or hard. So we're all very excited to sort of see how Frank responds to those as well. But I think in the interest of time, Frank, I think what we'll do is we'll kickstart. So welcome again, everyone. Thank you so much for joining us. What I'd like to do is officially introduce Frank. So although he's a man of that doesn't really require an introduction, for those who maybe not be familiar, Dr. Frank Heibel is a chartered professional electrical engineer with over 33 years of international experience in railway signalling. Widely known in the industry as Doc Frank, he has specialized in training and consulting for advanced communication-based signaling, including CBTC and ETCS technologies. Frank has advised several railway authorities in Australia and overseas on ambitious yet viable strategies for next generation signaling. Thank you so much again, Frank. I will hand it over to you, and the floor is yours.
Thank you very much, Fazi. Welcome, everyone. I'm quite excited to talk about two things today that are really, really close to my heart. The one thing is the modern train control. Anybody who followed me on LinkedIn ever will know that I'm posting a lot of stuff about these things, about ETCS, CBTC, and everything to do with high capacity signaling. If you don't know what ETCS or CBTC means, you are in exactly the right place, because I will explain that to you. The other thing that's close to my heart is that first bit in the title here, the understanding bit. So I really made it my mission to help people understanding these modern train control technologies, not just the signaling specialists to make them into whatever super specialist or uber specialist, but bringing these technologies closer to the wider rail industry, because I think the wider rail industry will be much more affected by those new technologies than previously for old signaling systems. So a couple of things about myself that Fazi has not already mentioned. My nickname, Doc Frank, actually was created here in Australia. I didn't have that when I migrated over from Germany. You can probably hear it from my accent that I'm not a born and bred Aussie. People here in the industry refer to me as Dr. Frank or Doc Frank, and I like the nickname. It just stuck, and well, ever since this is what I'm known for. I've been in the race signaling career my entire professional life, ever since leaving university. So 30 plus years is an understatement. It's now close to 34 years, actually. I spent 20 of those years with several global suppliers that all of you will know. In case you don't, I worked for Siemens, I worked for Thales, I worked for General Electric. So quite diverse companies with different cultures. The last 14 years I spent as an independent consultant, specifically for strategic topics around modern train control, and also as a trainer. I get back to that. So this combination, I've been on both sides of the fence, on the supplier side and on the client side. So I know quite a bit about how both of these camps think and work. And this really gives me a good understanding of the bridging between those two camps, which often can be quite diverse and have often enough struggle to understand each other. With regards to training, I've been doing official trainings for modern train control for over 10 years now. I started off with the CBTC live training in Sydney. The whole thing with live classroom trainings fell into a heap when a certain pandemic started in 2020. I'm sure you know what I'm talking about. And since then, I pivoted to something that I called live online training, something like this, where all of us sit in a virtual call. In these live online trainings, I can actually see your faces, and you can participate in asking questions like live via audio. So kind of similar to what we will be doing here with Informa in the so-called live interactive sessions. And for the last 2 or 3 years, I pivoted once more, going to full online trainings where all the lessons are recorded and you can watch them anywhere in the world, pretty much whenever you like. What may be kind of special, at least I like to think it's special about my training courses, that I have a so-called 100-100 objective. This is how I call it. It's not an official term. And that means that my objective is that 100% of people in my training courses understand 100% of the content. Now, if you let this sink in, this is quite a bold objective, but let's just take this as our challenge for today. So I'm actually hoping that some of you would consider yourself as a non-signaling person. Again, that's a definition that I came up with in contrast to a signaling person. And I think every one of you will be able to identify for yourself whether you would consider yourself a signaling person or a non-signaling person. If you think about it, that differentiation is actually quite clear. You may consider yourself as a half signaling person, but that's a bit like half pregnant. It doesn't really work. So I think you are in one camp or in the other. So I will present you a few slides where I teach you something. And at the end, we will do a little check how much you have actually learned. I hope you're up for that. So let's go. A couple of years ago, I was asked to do a presentation about high performance signaling, explaining what it means. And the first thing I came up with was a comparison between high performance signaling and conventional signaling, which is what most railways have today. So you see here on the left-hand side, the conventional signaling, and then you see on the right-hand side, the high performance signaling. And then I thought, wait a minute, there is something in the middle. So I introduced that third layer that I called protected signaling. And the difference between these three really is that the functionality, the number of features becomes more and better the more you go from the left to the right. So let's explain briefly what conventional signaling is. That's often also called fixed block signaling. That's basically what you see on most railways today. You see the lights on sticks, also called signals. And what you often don't see, or if you see it, you don't know what it is really the thing about fixed blocks. So I'm going to explain that. Railway lines all over the world are divided into block sections that are sometimes just called blocks because it's shorter, but block sections and blocks is the same thing. So this is like as a schematic how it will look like. At the bottom of the slide, you will see there's a railway line, or that's supposed to be a railway line, and then you have this division into block sections. And these block sections are divided by actual physical devices. There are different technologies for that, track circuits and axle counters, but we're not going to go into details on these things today. Just stick with it. There are devices that are mounted on the railway tracks in fixed locations, and they demarcate those block sections. Now, the purpose of these block sections is that they are safety zones for trains. That means a block section is a zone. When a train is in that zone, it's safe. Safe from what? Safe from other trains. So the basic signaling rule is that you can only have one train in one block section. Now, the signaling specialist will say, yes, Frank, there are exceptions to rule and so on. Yes, but only in degraded situations that you don't really want in your normal operation. So the standard rule of thumb, the signaling principle number one, if you will, is that you can only have one train in one block section. Now, how do you prevent other trains to get into the same block section? That would be a risk. They could collide, right? We don't want that. So block sections are protected by signals. So there is the concept of a red signal or a stop signal. And that means for any trains that's coming in from the left, that train would not be allowed to pass that stop signal. And that means there's no risk that the second train could collide with the first train by rear-ending it. Now, because of the braking behavior of trains have much longer braking distances than cars on the road, and that has to do with the friction between metal wheels and metal rails compared to rubber tires and atomic. There needs to be a warning that there will be a stop signal coming ahead. And that warning in the simplest of terms is a yellow signal, a warning aspect or caution aspect, one block section ahead. So what that also means is the block section needs to be long enough for a train to come to a standstill from traveling at normal line speed. And any signal before, I'm just showing you one, the other signals would be the same if there wasn't another train. The signal ahead would show a green aspect, which means proceed. And what the green aspect means is that the next signal coming will be either another green or a yellow. The yellow signal means the next signal will be a stop signal. There is no other meaning of a yellow signal. It's different than in road traffic. So if there was another train coming, that train would be allowed to travel. It would see a green signal, and everything is good. And that second train would be far enough apart from the first train, so there's no risk of a collision. There's another concept, and this is called overlap. And this is an additional safety measure to answer the question, what happens if the second train, for whatever reason, cannot stop at the red signal? Because the train driver didn't pay attention, started the braking process too late, maybe the rails were a bit slippery because it was just drizzling. And there's a risk that a train, despite the effort to stop at the red signal, may actually run past the red signal. And for these things, an additional safety measure is introduced, which is called overlap. And in fact, the train will only get a green signal, the second train that is, when the first train has actually cleared the overlap section. So what you can see here is that these two trains, these blue block arrows here, are quite far apart. So you can see there are three block sections between the green and the yellow and red, and then the overlap. There are three block sections apart. And given the positions or the worst case positions of the left train and the right train, it may even close to 5 block sections that trains are apart. And the length of the block section is the braking distance of a train, the actual worst braking train on that line. And that means these trains are very far apart. And that means you have capacity constraints where you can't run trains closer together in a fixed block signaling system. So this is what I just said, that the lengths of the block section reflect the braking distance of the worst braking train. So if you have a mix, say, of passenger trains and freight trains, you will say, well, yeah, but freight trains will take much longer to stop. The consequence is that they are only allowed to travel at lower speeds, which means that their braking distance will be about the same as the one for a passenger train with better braking behavior, which is allowed to travel faster. So I mentioned before these three levels of conventional signaling, protected signaling, and high performance signaling. And high performance signaling in this context here is nothing else than the modern train control that I'm talking about. So how does it work from signaling to train control? In a conventional signaling system, you've got these three levels of components. You've got the basic level where you have the signaling elements sitting along the track. So you have signals, the lights on sticks. You have points. These are the locations where trains can change from one track to another track. And then you have your track sections that are demarcated by elements such as track circuits and axle counters. So one level up, you have a component that controls all these field elements. And this is called an interlocking. So the interlocking, if you will, is the central safety controller for the entire signaling system. But then you need the third level where you actually operate and control the interlockings. And this third level is a control system. So sometimes this is called centralized traffic control. Sometimes this is called operational control. Sometimes in Australia, this is called train control. But this is a bit confusing because that train control, or calling the control system train control, is a different meaning of the train control that we are talking about here. And this is a typical Australian thing. I've never seen this anywhere else in the world. So this is the conventional signaling system, or the hierarchy of a conventional signaling system. And this will be the same everywhere. So you go to any railway, they will have a control system, something sitting on top controlling the interlockings. The interlockings will be the central safety controllers of the signaling system. And then you have the signaling elements in the field. So if we go from this conventional signaling one step up to what I call protected signaling, how does it look like? Well, you still have the same signaling components, but you have something else. And this something else is called ATP. And ATP is an acronym for automatic train protection. So, and the big difference here, and it really is a big difference for many railways, automatic train protection needs something on board of the train to actually provide that protection. You cannot protect the train without something sitting on the train doing that. So it's a computer that sits on the train and protects the train against two things: against running over red signals and against running too fast, overspeeding. And if a railway introduces ATP, it will be the first time ever that signaling equipment gets onto a train. And if you don't think that's a big change, let me tell you, it is. For the railway, definitely. What ATP also needs is a wayside subsystem, something that sits on the infrastructure that is able to talk to the computer on the train in an understandable language in order to give instructions to the onboard computer of ATP. So this is what I call protected signaling. It's a conventional signaling system with the same hierarchy, but with additional automatic train protection. And we have a few examples here in Australia where we have something like this. Adelaide, for example, has automatic train protection. Perth has had an automatic train protection system for more than 30 years by now, 35 years nearly. Brisbane has automatic train protection. Sydney now has automatic train protection. And Melbourne has something, well, kind of similar to that, which is a mechanical train stop system. So we have this ATP pretty much in all Australian cities. So now we come to modern train control, or in other words, high performance signaling. Sometimes this is called digital signaling. Sometimes this is called high capacity signaling. These terms are all more or less interchangeable. And the additional components, again, we're just adding something. We're not taking things away, at least not yet. Wait for a sec. At the moment, we're just adding something. So we have still our hierarchy of a conventional signaling system, of any signaling system. And in addition, we have automatic train protection. And now we also get additional automatic train operation, ATO. So what this does, it's a computer that actually drives the train, that can accelerate the train and can slow a train down all the way to a stop. And the third component that we have with modern train control is ATS. And this is automatic train supervision. Now, ATS specifically is a term that comes from a certain technology for train control, the so-called CBTC, communications-based train control. But the functionality ATS is pretty much a more sophisticated control system. So ATS would pretty much replace or augment the control system that's sitting at the top of the hierarchy. What can also happen, and what often does happen with the introduction of modern train control, you get changes in the bottom layer of the pyramid. So let's look at this, because there's going to change something in a moment. So what has happened now? You have replaced your line side signals, your lights on sticks, with something that's called cap signaling. What is cap signaling? Cap signaling means that in the train driver's cap, there is a screen on the driver's desk that displays the movement authorities. And that's a replacement of looking out of the window for signals. And what you can also have in modern train control, you see I have replaced the block sections with something better, with block sections that are optimized for higher capacity, which mostly means they will be shorter, quite a bit shorter, in fact. So this whole thing, everything that you see on this slide here, is what I call modern train control. And I said sometimes this is called digital signaling, sometimes this is called high capacity signaling, sometimes this is called high performance signaling. That's a term that I came up with, which I think fits better than high capacity. And another term for that is automatic train control. So that's a description of everything that you have seen on the last slide. There's a definition of automatic train control in a North American standard. That's a standard for CBTC. I already mentioned that technology. The standard is called IEEE 1474 Part 1. And the definition is that automatic train control must include automatic train protection. Remember, we had this on the last slide with the pyramid next to it, ATP. And it may include automatic train operation, and it may include automatic train supervision. Now, this definition may include was developed in the mid-1990s. If you look today, 2025, you will have ATO, you will have ATS. So it's no longer a may. You basically have to cut things back if you don't want ATO or if you don't want ATS. So you see that I highlighted some of those letters in a different color. And I want to take this as an example how I use certain tools to improve your learning and your memorization. So one is imagery. So in this case, I turned this text into an equation. ATC equals ATP plus ATO plus ATS. So some people that learn visually may learn easier using this equation than from just reading the text or me talking about it. Another way of helping is explaining the key acronyms. Because if you want to have discussions about modern train control with people who understand a lot about that, you want to know what these acronyms mean. If somebody talks about ATP and you ask, well, what do you mean by ATP? It kind of disqualifies you. And you ask the second question in a similar fashion, and they basically say, well, that's the idiot who knows nothing about signaling. Nice person, but not really a discussion partner for me. So we're explaining the key acronyms here. You see automatic train control, protection, operation, supervision. And another tool that I quite like using in my trainings is a so-called framework. So a framework, in my definition, is an acronym that stands for the first letters of certain things. So in this case, it's the so-called POS framework for the functionalities of automatic train control. So the P stands for protection, the O stands for operation, the S stands for supervision. And if you can memorize that for functionalities of modern train control, there's a framework called POS, then it will help your brain memorizing what the P stands for. Yeah, that was for protection. The O stands for operation. The S stands for supervision. The kicker is it's a 3-letter acronym. So there are only 3 functionalities, not 25. So many people say, oh, this train control stuff is so bloody complicated. No, it's not. 3. 3 is not a complicated number. 3 is everything you need to know. Everything fits in one of those 3 buckets. It's protection, operation, or supervision. And that also helps you debunking the myth that everything is so complicated and difficult and you should leave it to the signaling specialist or gurus or whatever you call it. This is all rubbish. People in the railway industry need to understand some foundations like this because they will be exposed to it. I get back to that in a moment. So for now, let's just do a little check what you have learned in the last 10 or 15 minutes. So that's an example for a knowledge check that I quite like doing throughout my trainings in between to really make sure that you can check whether you have understood and whether you can memorize all the things. If not, you can go back to the lessons and basically fill the gaps. So first question, you're not allowed to talk because you are muted, but everybody can check for themselves whether they know these things. So sorry, that was the wrong direction. So first one, block sections are zones for trains. What fits into the gap? Safety. And I'm sure I couldn't hear the answers, but I'm pretty sure most of you will have known that. So you have learned something, you have memorized this. Maybe you knew it already before, that's fine. But if not, then you have learned something new. Additional safety zones behind signals, how are they called? You probably remember overlaps. Third one, a train in a block section is protected by what? What prevents another train from entering into the same block sections? Yeah, it's a stop signal. What does the yellow signal mean? I explained this, you probably remember it. You had the red signal, the yellow signal, the green signal. Yellow means the next signal will be red or will show stop, whatever the stop aspect is in your signaling system. What does automatic train protection require on the train? For the first time ever, for railways that introduce a new signaling equipment on the train, because automatic train protection is a signaling feature. So you have ATP on the train. That means you have something that's part of the signaling world on the train. And automatic train control consists of how many main functions? It's not 25, it's not even 12, it's 3. And those 3 are, what was the framework? POS. So automatic train protection, automatic train operation, automatic train supervision. Now, if I was a betting man, I would be pretty sure that every one of you has answered pretty much every one of those questions correctly, which means that you have learned something. And especially the non-signaling people amongst you may have taken away something that you didn't know before, or you didn't put it into context. So based on this example of the last 10 minutes, what I already addressed briefly in a side remark, who needs signaling training? And I think this is changing dramatically during these times. Why? If you move from a conventional signaling system to automatic train control or modern train control or digital signaling or high capacity signaling, whatever you call it in your railway, this is a massive disruption of the railway industry, of the respective railway, of the respective city where you are in. Why is that? It may be the first time that signaling equipment gets on the train. There will be a step change in automation. If you introduce something like automatic train operation, where the driver takes the hand off the lever, this is a massive, massive, massive change for a railway. And consequently, you will have major changes how the railway is operated. If you go from a conventional railway to a railway with much higher capacity, that will have consequences to everybody, not just the train drivers, not just the signaling people, not just the people sitting in the control center, but for example, people working on stations. It will have a consequence. So I believe, and that's a strong premise of my entire presentation here, that signaling knowledge can no longer be held in a silo, in the silo of the signaling department, in the silo of the signaling people. It needs to be spread out in a wider fashion. So non-signaling people, for example, the service people on station platforms, suddenly need to know and understand at least a little foundation of this modern signaling, of this modern train control. Now, the question to each and every one of you that, again, you can answer for yourself, will you be affected? If the railway that you're working on, and I presume that all of you are working in some shape or form in the railway industry, in a certain city, in a certain region, so you will have your railway. If this railway introduces a modern technology for train control, will you be affected? If your answer is no, you may have overlooked something. So let's have a look at which technologies are there for automatic train control or for modern train control, whatever you want to call it. There are basically 2 mainstream technologies on a global level. That means that you can have pretty much any country in the world, for example, Australia, and you will be able to tender for and purchase any of those 2 global mainstream technologies. The first technology I already mentioned a couple of times is called CBTC, and this stands for communications-based train control. And that's the train control technology that's most common for metro railways, for so-called metro railways. If you think about something like Paris Metro, London Underground, New York Subway, Singapore Metro, places like this, they all have CBTC. Here in Australia, Sydney Metro comes to mind, which has CBTC everywhere. The other technology is called ETCS. And ETCS stands for the European Train Control System. And this is a technology that is more for mainline railways. Now, what's the differentiation between a metro railway and a mainline railway? A mainline railway is something that connects different cities. That's a mainline railway. Now, you will say, in Australia, what we have in pretty much all the cities is something kind of in between. Yeah, so you can have trains coming from other cities, but you also have many trains that just operate within the boundaries of the metropolitan area. And this is what I call suburban railways. We have this in Sydney, operated by Sydney Trains. In Melbourne, it's operated by Metro Trains Melbourne. In Brisbane, Queensland Rail is doing that. And in Perth, it's operated by the Public Transport Authority. Then we have the Adelaide Metro that runs the system there. So, and for those systems that sit somewhere in between a city railway with high capacity demands and a mainline railway, you can choose either or. And for all these cities, I have witnessed technology selection processes where CBTC and ETCS were the candidates, and one of the two was selected. Now, question for you, especially if you're not from Australia, which of those technologies is the one that will be used on your railway? By your railway, I mean the railway in your area, which you may be working on. Maybe you work for a consultancy, maybe you work for a supplier, but chances are, if your railway is introducing modern train control, it will be one of those two technologies. And the question is, which one? If you don't know, hit me up on LinkedIn with a direct message and I will be probably able to help you because I know quite a lot of things in the industry. So the next question is, once you know whether CBTC or ETCS is more relevant for your environment that you're working in, how can you learn about this? Especially, how can you learn about this when you only have very little or even no signaling knowledge when you decide you want to learn something about it? Now, one way is, and that's very popular these days, is, well, I just do self-learning. I have Google, I have Wikipedia, I have YouTube, I have all kinds of tools where I can learn something. That has some issues. Let's talk about those. So firstly, if you really start from zero, you have no idea what you need to learn. I want to learn about CBTC. That's not enough. That's not specific enough. If you say, I have an air conditioning unit of this model and I want to know how to take it apart and maintain it, you will find exactly the right video about this on YouTube. But if you have something vague and fuzzy and huge, like I want to learn about CBTC, well, yeah, you can look for CBTC videos. You will find some, and then you watch them, and you will see they are very superficial. They are sometimes even contradicting each other, and you say, well, it doesn't really help you. So the next issue is you don't really have any foundation. So if you get any new inputs, if you learn something new, you have no, you can't link it, which makes it difficult for your brain to really develop knowledge, to develop comprehensive understanding. I mentioned already contradicting information, and you don't have an anchor. You don't have something where you say, I know this is correct, and therefore I know that this is not correct. You don't have a structure where you really develop your knowledge step by step. There is nobody there who says an end game. So I want to learn this and this and this and this, and how this is how I get there. So I start teaching this first, or learning about this first, and then I need to learn about that, and then about that, and then I get there. You don't have this when you try this yourself. There's no curriculum, as they call it. If the whole thing takes too long, you may be very motivated on the first couple of days, but this motivation fades very quickly when you stumble about contradicting information and you can't find anything, and then you see in the comments, oh no, this is all rubbish. So motivation fades away quite quickly, and then life takes over. Eventually, you don't have the time and you just drop it, and you haven't learned very much, if anything. So this will really not solve your problem. Now, there are training courses, there are signaling trainings out there. So let's have a look how this works. And I'm talking about the typical signaling trainings that are often developed by signaling people for signaling people. And this is exactly what the issue is. So these typical traditional signaling training, they are aimed at signaling specialists. So if I'm talking about sophisticated technologies for modern train control, like ETCS, CBTC, the most likely application for this is that I take my signaling people and I try to give them additional knowledge for ETCS or CBTC. That assumes that those people already have a pre-existing foundation of signaling knowledge. If you don't have that, you've got a problem. These trainings also often use signaling jargon, so specific language using signaling terms, and also some acronyms that are considered as known. Automatic train protection, ATP, would be one of them. You hardly hear any signaling person talking about automatic train protection, automatic train protection. It's much too long. ATP is so much shorter, more convenient. People are lazy, so they throw around acronyms. ATP, ATO, ATS, MA, ETCS, CBTC. And if you constantly are in discussions coming up, well, what does this mean? What does this mean? You indicate very, very quickly to them that you don't know what you're talking about, and it's interesting as a discussion partner. So it may be embarrassing as well, constantly asking questions that seem to be obvious for everybody else in the room. So you just stop asking questions, which means you're not learning, you don't develop. And there is a risk, and I've seen this so often, that people sit in signaling trainings and it's like you're talking to them in Chinese. It goes straight over their head. And again, that means they don't learn anything unless they are already signaling people, signaling specialists, signaling experts. So what else is there? And I want to tell you briefly about my own approach to training. I told you that I'm focused particularly on people in the wider rail industry understanding what I have to teach. So it is aimed, my training is predominantly aimed at railway professionals, so people in the railway industry or people who want to get into the railway industry that have little or no signaling knowledge. The training is structured to really take you from a point A to a point B, even if the point A is pretty much ground zero with regards to signaling knowledge. The thing is, and I find this quite fascinating, I've found it fascinating for the majority of 10 years now, that signaling people coming into my trainings, which most of them are, they will learn a lot too. A classic example is somebody working on CBTC for more than 20 years, did my CBTC training, came back to me, said, I only wished I would have had this 10 years earlier. We could have avoided so many mistakes in our application of CBTC. So I'm going to provide a gentle introduction of basic signaling concept and terms. Not a full-blown training course, just the minimum viable dose to give you a platform from which you can learn about these modern train control technologies. And the lessons are timetabled. So it's not just, well, here are 35 lessons, take however long you like to learn it. I give you a structure, how you can timetable your learning and complete a training in a certain given period of time, which is finite. And there will be intermittent coaching calls in between. So even in an online setting, I'm not letting you hang out to dry with your training lessons, whether you understand them or not. There's an opportunity for you to ask questions all along. And there will be an opportunity for live coaching calls where you can interact with me face to face. And this has been proven over the last 10 plus years for hundreds of students in all kinds of different topics on CBTC, on ETCS, high capacity signaling, interoperability, you name it. So an example here for those visual learners of yours, that's the structure of my CBTC training. So I told you I get you from point A to point B, and point A could well be 0. And in this point A, you may feel overwhelmed or clueless with regards to CBTC. And on the other side, you feel confident and you feel knowledgeable. Confident means you're no longer afraid to go into a discussion with CBTC specialists, and you will stand your ground in there. So the way you get there is what I call milestones for results. So the first milestone would be to understand the signaling basics so that you're not starting completely underground. And I will also throw in these knowledge checks or quizzes that make sure that you really understood one level before you go to the next. Then the next milestone is talking about the foundations of CBTC. And to make you appreciate that it's not that super complicated, that's actually quite simple. Take this POS framework, for example, and frameworks are a classic tool that I'm using. The functionality framework for CBTC, POS. 3 functionalities. You will remember what it stands for: protection, operation, and supervision. So after that, we talk about a number of other things. We talk about functions of CBTC, the benefits, supply strategies, and this is all to deepen your understanding. And you get some knowledge that even many CBTC specialists don't have. Talk to people about supply strategies, and most of them will look at you blank. They don't even know what you're talking about. And I will explain to you why this is important and how you can apply it. And then lastly, there are tips and tricks for applying CBTC. And this is based on lessons learned. This is based on case study. It basically tells you this is how you do it right. And this is what you should avoid because you would be doing it wrong. And that takes again to that point B on the right, where you're not just more knowledgeable about CBTC, but you also have a confidence that there's a solid foundation of knowledge that you have mastered. Talking about mastering, my current trainings for CBTC and ETCS are called masterclasses. And that was, in fact, Informa's idea, not mine, but I quite like rolling with this because these trainings are actually amongst the best in the world. And the name masterclass, I think, is very fitting if you see what's all in there. So I did have pre-existing online courses for both technologies, one for CBTC, that's been my flagship training for more than 10 years, and for ETCS, which is around for about 5-6 years. So what I've done here together with the Informa Academy is to update these courses. That's what I've done anyway on an annual basis, bringing them up to date with the latest developments for those technologies. And for these master classes, I have also expanded the previous courses to make them bigger, to make them more comprehensive. By the way, what I did forget to mention, there's always something that you forget to mention. If you're still here, congratulations, stick with me. There will be a surprise at the end. I should have said this at the very beginning, my apologies, but just stick with it. The number is still pretty much the same as at the beginning. It just has gotten one more, so I'm pretty happy with that. Thank you very much for your persistence and for your attitude to stick along. So I think these courses are probably amongst the most comprehensive globally. It's difficult to say this is number 1 or it's number 2 or number 3, but I'm pretty confident these courses are among the top 3 trainings for CBTC and ETCS in the world. And I've seen other courses already as well, so I'm not talking completely out of my backside. They are suitable for beginners and advanced people alike. And this is really, I think personally, the biggest differentiator for my training courses. So you can have a very basic beginner thing. This is like the 2-minute YouTube video, how CBTC works. And yes, then you know something, but it's only a tiny little bit. This is not something that you want to boast about in a job interview or something like that. And then you have courses that are for advanced people. And this is the classic thing which goes straight over your head if you are not one of those advanced people already. The modules for both trainings are released over 6 weeks. So you've got a start date for the CBTC masterclass. A week later, you've got a start date for the ETCS masterclass. You're not going to do both trainings at the same time anyway. That's why I said before, which is the technology that your railway is using? Is it the one or the other? And at the start date, you get the first part, the first 1/6 of the content downloaded. A week later, you get the second portion, week later, the third portion, and so on. So we're doing this to keep your workload manageable. What I'm offering for these trainings, for both trainings, is a so-called immersion plan. So that's a suggestion for training over a period of 6 weeks with a manageable workload that's somewhere between half an hour and an hour per day, a little bit less on weekends because I'm a nice person. And this gives you a guideline how to learn that stuff and really get it done after 6 weeks. Not like sitting on it like 18 months later and oh my God, and I'm still not starting. And then you have a bad conscience. You feel sorry about yourself. Not with this one, not with the immersion plans. The video lessons have a total duration of about 13 hours for CBTC and 11 hours for ETCS. And if you know about CPD, continuous professional development, you can actually claim those trainings with 13 hours and with 11 hours respectively. And both Informa and I will back this up if needed. The courses include workbooks, which you can use to take notes. And I've had people who have used these workbooks as reference documents over years. They have it on their desk. Whenever they have a new piece of information, they look up where it fits into the workbook. They slot it in there, they print something, they slot it in there, they take additional notes. So it's really almost like the Bible of those people for CBTC or ETCS. I already mentioned the knowledge checks. So there are loads of them throughout the training course to basically make sure once you learn something, you can test yourself if you have really learned it, if you have really understood it. If not, you can go back and fill the gaps before you're missing something out for the later lessons that build on it. Discussion forum for continuous Q&A with me personally. So often in online trainings, you are left on your own devices, not here. You can, throughout the training, ask questions by just posting them in the discussion forum. And I will be in there on a regular basis answering them myself. I don't have Fuzzy doing that or any AI chatbot or so. It will be me. So you can directly communicate with me just via the discussion forum. And for both trainings, there will be 3 live interactive sessions. Zoom calls like this one, but your camera will be enabled, your audio will be enabled. You can actually talk to me and I will see you and I can talk to you. And those live interactive sessions will be in the 2nd, the 4th, and the 6th week of the 6-week training. So again, this helps you with some external milestones to really go in a structured way through the content of the entire training and get it done, get it finished, and not let it sit there for forever. Quick content of the CBTC masterclass training. We start talking about essential signaling concept and terms to basically create the same springboard for everyone. In the foundations, we talk about definitions, standards, purpose, and architecture of CBTC. And I've got another framework there, which is just as simple as the POS I talked to you about. We talk about data communications and do's and don'ts there. Key functionalities and benefits. Why are railways using CBTC in the first place, and where do these benefits come from? We're talking about the supply industry, And then important, the interoperability and supply strategies. And this is something that railways often underestimate or neglect at their own peril. And then we talk about case studies, lessons learned, do's and don'ts. And this is really where the rubber hits the road, where even the most seasoned CBTC specialists learned something new and said, well, if I had known this earlier, we could have avoided so many mistakes. Application tips, that's part of it. So it's not just knowledge transfer of the basics of CBTC. You get very advanced knowledge how to apply this, what to do and what not to do. So, and then a quick insight into the mindset that you need to raise the railway to higher capacity. For the ETCS masterclass, same starting point, essential signaling concept and terms. So to bring everybody on the same page, talking the same language. We have foundations as well, very similar to the CBTC masterclass. Then in ETCS, we have these different levels. We don't have this in CBTC. So obviously we need to talk about this. So we get to see all these different ETCS levels, what they mean and when they are used, what they are used for. Working principles of ETCS, very important. System requirement specification is a key document for ETCS. You will get some insights how to work with this thing. New features of the latest ETCS standards that came out in 2023. In railway terms, that's almost yesterday. And application tips. And again, very, very important and very different from standard basic ETCS trainings, which just talk to you about the functionality. Interoperability obstacles, something that hardly anyone will ever talk about because it seems to compromise a key feature of ETCS, which is interoperability. But if there is a risk to interoperability, you've got to know about this. Otherwise, well, you can't do anything about it. So you will see what are the potential obstacles and what to do about them. This is the strategies bit. And then lastly, something that many people consider impossible, how to use ETCS for high capacity. A quick extra here, because so many people have asked me for that, will there be any certification? Well, one thing is, if you completed the masterclass training, you will get a certificate, which is a certificate that you completed the training. But I wanted to take it, I wanted to have a certification process where I can personally assess your competency after the training, and I can give you a detailed certification of your competency that you can actually use in a job interview. And I've had people that did this and actually got jobs in CBTC after doing the training, after doing the certification. So if you want more information on this, there's a telephone number down here and an email address as well. My friend Dean will answer all of your questions and and get you sorted. Now, this is my last slide. I promised a surprise for you at the end. So as a thank you that you stayed here all to the end, you get a 10% discount on each on those training courses. So what I was talking about just a moment ago are these two courses here, the CBTC Masterclass that starts on the 28th of July and the ETCS Masterclass, which starts a week later. What I should also mention, you see this pinkish thing here, both of these trainings have been endorsed by the Railway Technical Society of Australasia, the RTSA. That's a subdivision of Engineers Australia. And let me tell you, those two trainings are the only signaling trainings in the country that have been endorsed by the RTSA. So this is something special. It's like a stamp of approval that these trainings really help people in the industry. And with this, I want to hand back to Fuzzy to talk about the registration process. And for those of you who have stuck around, thanks very much. We will have question and answers as well. So stick around to ask your own questions, get the answers, or hear what other people have asked and get answered to. Fuzzy, back to you.
Thank you, Frank. Thank you so much for that very in-depth introduction into understanding automatic train control. I personally learned a lot. Just a very quick a recap on what you can see on the slide there is there's obviously a very comprehensive list of courses that Frank has undertaken. Obviously, as Frank has mentioned, starting off with the first three essentials of rail signaling, CBTC masterclass, and the ETC masterclass as well. In terms of registrations, you can, if you want, take a quick photo of the slides, or obviously I'll go to informaconnect.com/academy and search for those particular courses just by using the search bar. As Frank has also mentioned, there is a 10% discount for those that would like to register, and if there is also a special offer for people that would like to register for more than one course. The best way to take advantage of that discount is to contact my colleague Dean on the information provided, his contact number or email address. He will be more than happy to talk to you and provide further information in relation to those courses. We are, like Frank said, more than happy to take questions at this point in terms of any queries they have. We've already had some come through, Frank, so I might just jump straight into those. There's been a couple of comments as well, which I might get you to provide some responses to. The first one, I think, and we'll go in chronological order, but this is from Ryan. Ryan made the comment relating to suburban railways have a very unique headway envelope and a very unfavorable speed and braking profile. So that was his comment. I'm not sure if you've got anything to say in response to that.
Um, I don't really find this, to be honest. The trains, the suburban trains are in many cases quite modern, and you can definitely apply the principles of modern train control to increase capacity. Maybe you don't quite get the same effects out of there as you would get for metro, where you have specialized trains with extremely good acceleration and braking performance. But that doesn't mean you can't do anything at all. You can still apply these technologies to the suburban operations, and we are showing this as we speak in all the major Australian cities. Perth has just contracted CBTC mid last year, and they're now starting to roll it out, and they will be able to increase their potential capacity by more than 150%. So to me, that indicates that suburban railways are very, very suitable for doing these things and can really provide a massive, massive uplift of capacity everywhere.
Sure. Bahadur, my apologies for the pronunciation. Their question is, Hi Frank, how is the introduction of FRMCS going to change ETCS and CBTC? The new 5G or LTE based communication can change the whole communication layout for both of these systems.
It does, and I'm talking about both of these things in the masterclass training. I mentioned for the ETCS masterclass, there's a completely new module, which I did just for this masterclass, with new features that came with the latest version of the ETCS standards. And FRMCS, the Future Rail Mobile Communication System, is part of that. Yeah, I've got views on that, and I don't want to go into too much detail here, but it will definitely change the landscape of ETCS quite significantly. And there's also a potential that in the future, FRMCS could be used for CBTC, which would be one step for kind of merging these technologies, at least in parts, not making them alike, but bringing them closer together. And a city having in the future FRMCS radio could have both CBTC and ETCS applications, and they both could use the same radio technology, which today doesn't work.
Understood. I'm not sure if this is enough there to be able to offer a comment, but I'm going to ask the question anyway. Mark is asking CBTC to ETCS interface. I'm not sure if there's enough there to provide a comment on that.
Don't do it. Don't do it. It's there's only one example that I can think of where this has ever been tried. And that's the Crossrail project in London, which today is called Elizabeth Line. They have spent years on that interface. It brought them into a world of pain. So normally you have a very clear differentiation and also separation between railways that operate on CBTC and railways that operate on ETCS. A good example in Australia is Sydney, where you have Sydney Metro using CBTC, You've got the Sydney Trains network using ETCS, and both networks are completely segregated without any physical connection of tracks. And this is how it should be. And if you do that, then you don't need to consider interoperability between those tools. You don't need to consider any interaction transitions or whatever. The problem just goes away.
The next one, I think we've already sort of covered this, but I'll make a point of covering the question anyway, Frank. It's from Tim. Tim is a rolling stock engineer in Brisbane looking to build understanding of modern signaling. I think he asked this question a little bit earlier in the piece, but he was asking, will the ETCS Kickstarter training become available again? Which obviously that has now become the ETCS Masterclass. And he was making a point about he was not able to find it online. So this is now
Yes.
the conversion of the Kickstarter into this new program.
Yes, well, that's the consequence of me working now with Informa. The Kickstarter trainings will no longer be offered. I've been out there on LinkedIn stating that. What I want to do over the next couple of days, I just didn't have time so far. I will go back on my own website and my own training portal and will establish the ETCS masterclasses, CBTC masterclass, and so on with links to the Informa portal. So these Kickstarter trainings are just over. The masterclass trainings are better. They are more comprehensive. They have more interactive elements. And yeah, I'm sorry. With regards to the Kickstarter, I must say you missed the train, literally.
Next one, Frank, is from Paula. Paula has asked a couple of questions. She is, I'm already taking some of the blueprints as an electronics electrical engineer. I'm in the ARA Women in Rail mentoring program with my mentor. I'm learning all about ETCS, including subsets. I am currently working in some projects with my consulting company, but how to actually get into some of the ETCS projects to apply what I've learned with you and with my mentor.
Well, doing the masterclass is obviously a good thing to learn more about ETCS. With regards to getting into a project, I'm not quite sure whether you want to get into a project and how to use the training as a springboard for that, or whether you just ask how to get into a project without. I mean, how to get into any project is to find people who already work there, befriend them, so connect with them on LinkedIn or whatever, get in touch with them, wait for opportunities on those projects, and they will come hard and fast, and then apply for it. And then ideally, in a job interview, demonstrate that you already have some ETCS knowledge. And I can only say that masterclass training will help you. It won't guarantee a job, obviously. I mean, if you are just being stupid in a job interview, you won't get it, regardless how much you know about ETCS. But from experience, these trainings really help to demonstrate a solid foundation of knowledge in a job interview, to the point where people will say, oh, this is nice, we will teach you about the rest.
Very good. Paolo asks the question, do the systems CBTC and ETCS communicate with each other?
No, they don't. As I said before, these are basically two completely different words, which also belong to two almost different types of railways. I said that the suburban railways are somewhere in the middle, but even somewhere in the middle, at the end of the day, the railway needs to make a decision. Do they go CBTC or do they go ETCS? And the two together, it's a bit like oil and water. That doesn't mix very well.
Got it. A follow-up question from Mark. I think he was asking about the CBTC to ETCS interface. His follow-up question is, what about ATMS interoperability with CBTC and or ETCS?
Well, for ATMS, which is the Advanced Train Management System, that was a development that was done for the interstate network here in Australia. And I'm talking a lot about this in one of my courses, which is down there, third from the bottom, digital signaling interoperability. The latest thing I heard is that ATMS will be abandoned. I don't see this being rolled out on the interstate network. And that means this whole topic of making it interoperable with ETCS or CBTC just goes away. Yeah, it's not public yet what the interstate network will use instead, but it's very likely that it's not going to be ATMS. which is a shame given how many years they spent on that and how much money they spent on that. And I think it's a great case study. Better not to work with a non-railway signaling supplier in the field of railway signaling.
Very good. Oh, I was about to say I think we've finished up with questions, but there is one more that's just come through. JD is asking which OEM products, I think you maybe just mentioned products, typically are done hands-on, only theory. Uh, it helps in railways where no specific OEM equipments are handled if you are to maintain the section.
Yeah. Um, my trainings are product agnostic. So I'm teaching the foundations. The thing is that the products for CBTC specifically, but also for ETCS, they differ quite a bit between suppliers. So and the deeper you go, the more they differ. If you think about things like design tools, programming tools, um, the the finer details of the architecture, they're all different. So it would not be possible for teaching on every product in the marketplace. And if I only pick one or two, it's almost guaranteed that somebody else will come in and say, yeah, but I'm interested in the other one. So you will only deal with the specific products if you, for instance, work for a supplier and that supplier will give you product specific training, or if you work in a project where you can use the foundation from my training to then build up on the project specific stuff or the product specific stuff. Yeah, I didn't see a practical way to cover product specifics. And it's also an IP thing, all kinds of stuff. I mean, the suppliers probably wouldn't let me train on their products without doing it through them. And then this is just a completely different avenue of training. So the upside is that these trainings, these masterclass trainings, will be understandable for everyone, and you can apply this knowledge on any product that you're dealing with. Yeah, you may find that some suppliers use slightly different terms. We talk about this as well, but you will be able to communicate with those people that know about those products. And if there's a need to learn anything on top of it, product specific, you will be able to link it much better with your existing foundation than if you didn't have that.
I know that the time is of the essence, Frank, but so we might just do two more before we wrap up. We've got this question from Kumar. What is communication technology? I think he says, which communication technology is used on cab signaling?
Well, it's not specifically with cab signaling. It's there are different radio technologies used for these two technologies. For CBTC, Wi-Fi is still the most popular radio technology, even though there are lots of problems with that. And I talk about this in the masterclass training. The alternative for CBTC is LTE or 4G radio. That's the standard radio system used for CBTC in China, for example. And it will also be used here in Perth for the CBTC application here. For ETCS, traditionally, it was a system called GSMR, which from a telecommunications perspective is Stone Age. Yeah, it was modern in the mid 1990s, but we are now 30 years further down the line. And 30 years in the telecommunications industry is an eternity. So, and now for ETCS, we're talking about the transition to a new radio technology that was mentioned before, FRMCS. And again, in the masterclass, we will talk about this. We will talk about migration challenges and all kinds of things. So the industry is at an interesting transition period. And I think it will be a major challenge for applications, for example, here in Australia, but also in New Zealand over there, how to migrate to a more modern, future-proof radio technology for ETCS.
Lovely. And last but not least, Frank, what system is typically employed by MTM for conventional signaling?
Well, for conventional signaling, Melbourne, so MTM is Melbourne, that's Metro Trains Melbourne, the operator running the suburban operations in Melbourne. For conventional signaling, they have a conventional signaling system with signals. They have two aspects sitting on top of each other, and the combination of this is something that I'm actually talking about this specifically in the essentials of rail signaling training. And that training, I'm talking about signaling principles to an extent, and Melbourne is in fact one of the examples that I'm using there in comparison to a simpler signaling system for which I take Perth as an example. They have point machines, they have track circuits for the block sectioning, they have level crossings, even though they're trying to get rid of those over time. And they have something that I mentioned briefly, mechanical train stops that are basically arms, levers that sit next to a signal that come up when the signal is red. And if a train runs past that signal, there's a brake valve underneath that will hit the lever, ripped open, air goes out of the braking system, and train stops. So it's very old mechanical technology. With regards to modern technology, Melbourne is now applying CBTC on the metro tunnel project, including the approaches from both sides. But in the future, it's more likely that they will transition to an ETCS-based strategy, but this is not yet public knowledge, but it indicates that I know, yeah, maybe a bit more than what you see in the public domain. And as a training participant, you will participate in all of that. And what I hope, and maybe as a closing remark when we come to an end here, I hope what you have seen is that these Q&A sessions with me, especially the flexible ones where people can start questions, get an answer, ask a follow-up question, they are masterclasses in itself. So I had Q&A sessions that were way beyond the actual content of the training course because it can be much more specialized related to the questions. So maybe there's another plug that this is really a worthwhile experience. And I must say, I hope very much that I see at least some of you at those trainings. Maybe you find somebody who has done a previous training with me, one of the Kickstarter trainings, and I'm pretty sure you will hear only positive things about those.
Lovely. Well, I think with that final comment, I think we'll close it there, Frank. And thank you everyone for attending. We really appreciate your sticking through right till the end. Thank you so much, Frank. That, like I said, that was very illuminating, and I appreciate your spending some time with us to deliver that content. And like I said, we're also very excited to be working with you with delivering all this very wide-ranging curriculum of training around rail signaling. So with that, thank you all for joining us.
Final word, stop. Final word from me. If you take one thing away, one, signaling is not rocket science when it's explained properly. So if that's the only thing you take away from here, that's already a success from where I'm sitting. And if that encourages you to learn more about signaling, to learn more about even these so-called sophisticated technologies like CBTC or ETCS, then it's an even bigger success. So thanks, Fadi. That was it from me.
Lovely. Thank you, everyone. Thanks for joining, and we'll be in touch with you very soon. Take care. Thank you.
Bye, everyone.